Good evening. Continuation of the lecture series Electromagnetic Fields. Today we are going to discuss on Gauss Law and applications. Gauss Law is one of the Maxwell's equations which describes the relationship between electric charge and electric field. It states that the total electric flux through a closed surface is proportional to the total charge enclosed within the surface. Mathematically, Gauss Law is expressed as closed surface integral E dot dA, which is equal to Q enclosed by epsilon, where integral E dot dA is the total electric flux through a closed surface S. Q enclosed is the total charge enclosed inside the surface. Epsilon naught is the permittivity of free space, which holds the value 8.854 into 10 power minus 12 coulombs per meter square. How to prove the Gauss law? The Gauss law can be realized using a point charge, and for any point charge, a spherical surface of radius A is chosen around the charge. The electric field at every point on this surface is radial and has a constant magnitude E. Whereas the Gauss law E dot dA is equal to Q enclosed by epsilon shall be proved by considering a imaginary surface, that is with a point charge. Let us consider a point charge Q placed at the origin. The electric field at a distance r from the charge is given by Coulomb's law. E is equal to 1 by 4 pi epsilon naught r squared into Q. So now considering a spherical surface of radius r, which is chosen around the charge, the electric field at every point on this surface is radial and has a constant magnitude E. The total electric flux through the spherical surface is closed surface integral E dot dA, which is equal to closed surface integral E dA cos theta. Since cos 0 is equal to 1, we will get closed surface E dA. E is constant over the sphere. It can be taken out of the integral. So, in E integral dA, the total surface area of the sphere is 4 pi r square. So, E into integral of dA is 4 pi r square. Substituting E is equal to 1 by 4 pi epsilon Q by r square, we get 1 by 4 pi epsilon r square into Q into 4 pi r square. Finally, integral E dot dA is equal to Q by epsilon naught. By superposition principle, if multiple charges are enclosed in the surface, the total flux is the sum of individual fluxes. Thus, for any charge distribution, closed surface integral E dot dA will be equal to Q enclosed by epsilon naught. This is Gauss law. There are few applications of Gauss law. By applying the Gauss law equation, we can find the electric field intensity or flux density of any kind of charge distribution. For example, electric field of a spherical charge distribution can be identified. Take for example an iron ball can be identified. Electric field intensity of an infinitely charged wire. Consider a conductor or a transmission line. The electric field intensity can be identified by applying the Gauss law. And the electric field of an infinite plane sheet of charge. Any field intensity of a charged conductor, let us consider a solar panel or a charged disk, can also be identified by applying the Gauss law. And finally, the field of a charged conducting shell. Whereas shell is nothing but a spherical surface with different radii. So all these can be identified by applying the Gauss law. And two laws that governs electrostatics are Coulomb's law and Gauss law. We have already discussed about Gauss law can be applied over the surfaces where the surface is not the charges are not uniformly distributed over the surface. Any kind of surface charge can be identified by easily approximating that surface to the Gaussian surface or regular Gaussian surfaces. Whereas Coulomb's law is used to identify the charges that is distributed uniformly everywhere. Hope you understood this session. Thank you for listening. Thank you.